Data Science Rabbit podcast with Michael Bagelman.
Dear listeners, welcome back to the Data Science Rabbit podcast, where today you find yourself in the capable and, dare I say, unparalleled hands of Cornelius P. Snarkington, the data scientist nonpareil. Yes, indeed, Michael Bagelman has entrusted me to take the helm for this first of several Halloween-themed episodes. And naturally, we begin with a subject as spine-chilling as it is intellectually perplexing: werewolves. Now, if you are fortunate enough to be blissfully unaware of the game of Werewolf, allow me to introduce it. Picture, if you will, a group of otherwise rational human beings devolving into a delightful mix of deception, accusation, and sheer paranoia. The premise is simple. Players are divided into two factions: villagers and werewolves. Each night, the werewolves eliminate a villager, and each day, the villagers frantically attempt to uncover the hidden wolves among them. What follows is a chaotic exercise in social deduction that inevitably leads to mistrust, finger-pointing, and of course, accusations as wild as the beasts themselves. But fret not, for we are not here merely to revel in the macabre, though the allure of Halloween does beckon. No, today we delve into something far more intriguing: the application of artificial intelligence to this very game. Yes, my dear listeners, the fine minds of Google's Notebook LM Deep Dive team have explored the application of machine learning and AI to this dark corner of human interaction, and we shall discuss several academic papers that analyze this game with eerie precision. So, stay tuned if you dare. But heed this warning. Only those with great courage should continue, for we are about to venture into the uncharted territory where data science meets the supernatural. This is Cornelius P. Snarkington, and you're in for quite the spectral journey.
In the depths of night, when shadows lengthen and whispers curl through the air like tendrils of mist, a sinister game unfolds. They call it Werewolf, though some know it by its equally ominous moniker, Mafia. Gather round, ye mortals, and hearken to the tale of this accursed pastime. As darkness falls, the players huddle in a circle, their faces flickering in candlelight. Each is given a secret role, known only to themselves and the eldritch entity known as the Moderator. Among them lurk the werewolves, creatures of nightmare who walk as men by day, but transform into ravening beasts when the moon rises. The game cycles between two phases, as regular as a ticking clock counting down to doom. First comes the night, when all close their eyes and the werewolves awaken. With silent gestures, they choose their victim, a poor soul to be torn asunder before the coming dawn. Then arrives the day, harsh and unforgiving. The chosen victim is revealed, their fate sealed by tooth and claw. The survivors, gripped by paranoia, debate and accuse. Suspicion hangs thick in the air, a miasma of fear and distrust. By majority vote, they condemn one among them to death, hoping to root out the beasts that hide in human skin. But beware, for in this game of deception, nothing is as it seems. Innocents may be sent to their doom, while the true monsters escape justice. Special roles lurk in the shadows: a seer who can pierce the veil of lies, a doctor who can stave off death's embrace, and others whose powers tip the scales of fate. The cycle continues, night and day, until either all werewolves are vanquished, or their numbers equal those of the villagers. In that grim moment, the beasts would overrun what remains of civilization, their howls of triumph echoing through the empty streets. So gather your wits, steel your nerves, and pray to whatever gods you hold dear. For in the game of Werewolf, trust is a luxury none can afford, and death waits behind every accusation. Will you unmask the monsters, or become another victim in their endless hunt?
All right, so today we're diving into something pretty wild. AI playing werewolf.
Yeah, you could say that again.
I mean, seriously, you send over these research papers, and it's not just about teaching a computer the rules of the game. It's like...
It's about psychology, right?
Exactly. It's about reading people, knowing when they're lying, figuring out who to trust.
All that stuff that makes werewolf, or mafia as some folks call it, so compelling.
Totally. And now we're talking about AI doing it. I mean, even for us humans, it's like navigating a minefield of suspicion out there.
You're telling me it's a game that really digs into our social intelligence.
Right. So before we get into the nitty-gritty of how researchers even began to tackle this, let's make sure everyone's on the same page. Imagine trying to explain werewolf to a computer.
Okay, so at its core, werewolf is all about hidden roles and deception. You've got your group of players, some are villagers, just regular folks, and then you've got...
werewolves hiding in plain sight.
Exactly. And the villagers, their goal is to sniff out those werewolves.
And give them the boot, so to speak.
Precisely. While the werewolves are trying to blend in, pick off the villagers one by one.
And don't forget, most of the action happens at night.
Oh, absolutely. That's when the real drama unfolds.
Right, so you're relying on what people say during the day, how they act, to figure out who's who.
Trying to read between the lines, catch those little slips, those tells that betray someone's true allegiance.
And that's what I find mind-boggling. How do you even begin to program an AI to pick up on those subtle cues? The hesitation in someone's voice, the way their story doesn't quite add up.
It's a massive challenge, no doubt. And that's where these research papers get really interesting. They're all tackling this question of AI deception from different angles.
Right, like that first paper, the one about Deep Wolf.
Ah, yes, Deep Wolf.
Yeah.
That one took a pretty fascinating approach.
They trained it on text chats from human werewolf games.
They did, but with a clever twist.
The pronoun swap. That's the part that really blew my mind.
It's brilliant when you think about it.
It's like they scrambled up the dialogue so the AI wouldn't get hung up on who said what, but could instead focus on
the underlying patterns of deception, right?
Yes. Like, how do people talk when they're trying to lie, regardless of whether they're a werewolf or a villager?
Think about it this way. You can often tell someone's lying even if you don't speak their language. There's something in their tone, their body language, that gives them away.
It's like a universal language of deception.
Exactly. And this Deep Wolf AI, by analyzing thousands of these pronoun-swapped conversations, it started to pick up on those telltale signs, those linguistic fingerprints of a lie, regardless of who is doing the talking.
So they taught the AI to understand the language of lying.
In a way, yes. They equipped it with the tools to decipher the subtle signs that betray our true intentions, even when we're hiding behind carefully chosen words.
And what's even more amazing is that it worked. It actually worked.
It did. Even though Deep Wolf was trained on games where the werewolves and villagers won about half the time, it quickly figured out how to gain an edge.
So it's not just mimicking, it's strategizing. Like it's learning the odds, adapting its game.
Researchers found that the AI could accurately size up the state of the game. It even understood that in the 5-player version they used, the villagers have a slight advantage.
Wow, it's like this AI is a natural-born werewolf player.
It makes you wonder, are we sure this is just a computer program and not some secret werewolf grandmaster pulling the strings from inside the machine?
Laughs, I assure you, it's all algorithms. But the results are definitely impressive. It's a clear sign that AI can grasp complex game theory, even when it comes to something as psychologically charged as werewolf.
Okay, so maybe not a grandmaster yet, but definitely a quick learner. But there was a catch, right? It wasn't like Deep Wolf was inventing some whole new way to play the game. That's an important point. Deep Wolf was working within a set of limitations. It could only make moves it had observed in the human games it studied. It wasn't building entirely new strategies from scratch.
Okay, so a brilliant student, but not quite a revolutionary player.
Exactly.
Which makes that next paper even more intriguing. Because that's where we ditch the rule book and bring in the big guns, right?
Yeah.
Large language models, LLMs. We're talking about the same technology behind ChatGPT.
Yeah, things are getting really interesting. Yeah, LLMs, this is where we really start to push the boundary.
Right. It's like we went from giving the AI a textbook to dropping it into a high-stakes poker game.
Telling it to learn from the sharps, yeah.
Exactly. But, werewolf conversations, they can get pretty complex. There's so much going on, so many layers of...
deception, alliances, you name it.
Right. So how does an LLM, even a super sophisticated one, keep up with all that? I mean, they talk about context windows, right?
Yeah, that's the thing with LLMs. They have a limited amount of information they can process at once, like a snapshot in time.
Okay, so if it's only seeing a small chunk of the conversation, how is it supposed to understand the bigger picture?
That's the million-dollar question, and these researchers came up with a pretty ingenious solution. They realized that instead of overwhelming the AI with the entire game,
They gave it the highlights.
exactly, they basically created a system that pulled out the most important moments, the turning points in the game.
Like a Werewolf Greatest Hits album.
Laughs. I like that. So instead of listening to every single word, the AI was fed these crucial snippets, these key exchanges that revealed the most about the players and their strategies.
So it's like, okay, AI, you don't need to see every hand, just the ones where someone bluffed masterfully or made a game-changing move.
Precisely. It was all about focusing the AI's attention on the moments that mattered most.
That's so clever. But they didn't stop there, did they?
Oh no, they didn't. They took it a step further. Remember how Deep Wolf was trained on a set of human games? Well, these researchers took that idea to a whole new level.
Let me guess, they built like a mega library of werewolf games.
Exactly. They called it an experience pool, and it was massive. This pool contained data from thousands of werewolf games, all neatly categorized and ready for the AI to analyze.
So it's like giving the AI access to the collective wisdom of all werewolf players throughout history.
That's a great way to put it. And what's really mind-blowing is that it worked. When they pitted these experience-enriched LLMs against each other, the ones playing as villagers, well, they became masters of the game.
No way. They actually got better.
Significantly better. They were winning more, surviving longer, making smarter decisions. It was like all those hours spent in the virtual werewolf library had paid off.
That's incredible. So the villagers are basically soaking up all this werewolf knowledge, learning from the best or worst, depending on how you look at it.
Right. But here's where it gets really wild.
They're kidding. There's more.
The AI werewolves, the ones who didn't have access to this experience pool, even they started upping their game.
Wait, what? Just by playing against the smarter villagers?
Exactly. It was like they were learning in real time from their opponents, adapting their tactics as the villagers got tougher to fool.
So we've got AI villagers with access to a massive database of werewolf strategies, and we've got AI werewolves evolving their game just by playing against these masterminds. This is like an AI arms race.
It's amazing, right? And it gets even weirder. Remember how we talked about those subtle cues, those hints of deception that humans pick up on? Well, the researchers noticed something fascinating in the AI werewolves.
Don't tell me. They started exhibiting those same cues.
They did. They weren't explicitly programmed to do this, but through sheer exposure to the game, these AI werewolves started developing their own deceptive strategies.
Hold on. Are you saying that the AI figured out how to lie, to manipulate, to build trust, and then break it all on its own?
It appears so. They weren't told how to be deceptive. They learned it by playing the game, by observing how the other players, both human and AI, interacted with each other.
That's both fascinating and a little terrifying. It's like we've opened up this Pandora's box of AI intelligence, and we're only just beginning to understand what's inside.
And remember, these were just the AI werewolves who didn't have access to the experience pool. Imagine what the werewolves who did have access could learn to do.
This is blowing my mind. But for all the amazing things these LLMs could do, they were still relying on language, right? Analyzing text, learning from conversations. But what about those other approaches to AI? The ones that are less about words and more about, well, pure strategy. It's like we've entered a whole new dimension of AI. It's not just about understanding language anymore, it's about cracking the code of strategy itself.
Exactly. And with this Q learning approach, it's all about optimization.
Right, like finding the absolute best move no matter what.
You've got it. Think of it like this. Instead of learning from human games, we're putting the AI in a virtual werewolf boot camp.
A boot camp.
Yeah, like a training ground where it can play thousands, even millions of games against itself, trying different strategies, seeing what works.
So it's basically learning by trial and error, but on a massive scale.
Precisely. And the key here is the Q in Q learning. It stands for quality, and it's all about the AI learning to associate certain actions with their outcomes.
So if it makes a move that leads to a win, it gets a little virtual pat on the back.
Exactly. It's like giving a dog a treat for learning a trick. But in this case, the treat is victory. Over time, the AI builds up this internal reward system, a kind of mental map of which actions are more likely to lead to success.
So it's not about mimicking human behavior or understanding the nuances of conversation. It's about cold, hard strategy.
You got it. With Q-learning, the AI is laser-focused on optimizing its chances of winning, even if that means making moves that we humans might consider a little, shall we say, unsporting.
So it might not be the AI you'd invite to your weekly game night, but it might be the one that cleans you out every time.
Less. Quite possibly.
But as fascinating as Q-learning is, this last paper we're going to look at takes a completely different approach.
Oh yeah, this one dives into some seriously deep waters.
They're talking about giving AI something called an extended BDI model. And honestly, that sounds a little intimidating.
Well, get ready to have your mind blown, because BDI stands for beliefs, desires, and intentions.
Beliefs, desires, intentions. It's like we're not talking about AI anymore. We're talking about, us.
Exactly. This is about trying to understand the very core of how humans think, how we reason, how we make decisions, and then translate that into algorithms.
So instead of just programming an AI to play Werewolf, we're trying to build one that actually thinks like a werewolf player.
That's the goal, and it's a tall order. The idea behind this extended BDI model is to create AI agents that can hold beliefs about the game and other players, even if those beliefs are incomplete or uncertain.
So it's like they can be suspicious, they can have doubts, just like us.
Exactly. And not only that, but these BDI agents can also have desires, things they want to achieve in the game, and intentions, plans for how to achieve those desires.
Hold on, so we're talking about AI that can strategize, not just based on the rules of the game, but on what it believes about the other players.
Exactly. They can even reason about the beliefs of others, trying to figure out, okay, if I were this player, what would I be thinking right now?
It's like they're playing a game within the game, a mental chess match, where the pieces are other people's thoughts.
It's incredibly complex, and we're still in the early stages of this kind of research, but the potential is mind-blowing.
I mean, just imagine the possibilities. If we can build AI that understands human beliefs and desires, it could revolutionize everything from how we interact with technology to how we understand ourselves.
Absolutely, and that's what makes this whole deep dive so exciting. We've gone from teaching AI to play a simple game of Werewolf to exploring the very nature of intelligence, both human and artificial.
It's been a wild ride. From pronoun-swapping AIs to virtual werewolf boot camps, from the language of deception to the algorithms of belief, we've covered a lot of ground today.
We certainly have, and it just goes to show that even a game as seemingly simple as Werewolf can open up a universe of possibilities for AI research.
It really makes you think, doesn't it? Where will this technology take us next? What other human endeavors will AI learn to master? And how will our relationship with these intelligent machines continue to evolve?
Those are the questions we need to be asking ourselves as we venture further into this uncharted territory. The future of AI is full of potential, but it's up to us to guide its development responsibly and ethically.
Couldn't agree more. And on that note, we're going to wrap up this deep dive into the world of AI playing Werewolf.
It's been a pleasure joining you.
A huge thank you to you, our expert, for sharing your insights, and to you, our listeners, for joining us on this journey of discover. Until next time, keep exploring, keep questioning, and keep those AI wolves at bay.
For anyone who would like to learn more about applying AI to the Werewolf game, here are the papers that were reviewed today. Playing the Werewolf game with Artificial Intelligence for Language Understanding by Shibata, Miki, and Nakamura, 2023. This paper discusses the development of an AI agent capable of playing werewolf through natural language conversations. The researchers fine-tuned a language model to predict winning probabilities and used it to create an AI that could interact with humans in the game. Exploring large language models for communication games, an empirical study on werewolf by Xu, Wang, Li, et al., 2023. This study explores how to engage large language models, LLMs, in communication games like Werewolf. The authors propose a tuning-free framework that keeps LLMs frozen and uses retrieval and reflection on past communications and experiences for improvement. Optimal Strategy in Werewolf Game, a Game Theoretic Perspective, by Wang, 2023. This paper examines optimal strategies for the Werewolf game from a game theory perspective. It proposes an improved Random Strategy Plus for games without a profit and explores perfect Bayesian equilibrium strategies for games with a profit. Tracing Werewolf Game by using Extended BDI Model by Nide and Takata, 2016. This paper introduces an extension of BDI, belief, desire, intention, logic, that can handle probabilistic mental states. The authors use this extended logic to model situations in the werewolf game, including representations of agents' speech acts and state transitions. Using Q-learning and estimation of role in werewolf game by Hagiwara, Mustafa, and Ito, 2019. This paper proposes a novel strategy for playing werewolf using reinforcement learning, specifically Q-learning and role estimation. The author's model uses Q-learning to decide actions and a naive Bayes classifier to estimate other agents' roles, showing improved performance in 11-player werewolf games.
Dear listeners, thank you for your unparalleled bravery in joining me on this harrowing journey through the dark and treacherous world of digital minds playing the murderous game of werewolf. I commend your courage for facing such chilling subject matter. One can only hope you have emerged unscathed. But beware, more terrifying Halloween-themed episodes are soon to follow, where we will explore even deeper, more sinister corners of data science, provided the creatures of the night don't find you first. Until then, keep your wits sharp, your data clean, and your lights on. For the Data Science Rabbit podcast, this is Cornelius P. Snarkington, signing off, hopefully before the werewolves come knocking.
This has been the Data Science Rabbit podcast, hosted by Michael Bagelman. Find the Data Science Rabbit podcast on all your favorite social media, including YouTube and TikTok. Follow Michael on LinkedIn or visit datasciencerabbithole.com.